that we need us to apply the L'Hopital's rule of differentiation. Alright, so quickly, before we apply the L'Hopital's, we need to see into using direct substitution. And by direct substitution, if the solution to this problem gives us an indeterminate form, any of the indeterminate form, it means it's not a solution. Then you have to try another method. So the first method I want to try is the method of direct substitution. We have limit of 1 over x minus 1 over x cos x as x approaches or tends to 0. So by direct substitution, anywhere we see x, we substitute this 0. So I will have 1 over 0 minus 1 over 0 cos 0. And this, we have 1 over 0 minus 1 over cos 0 is 1. And 0 times 1 is 0. So this will give us 0 over 0. And 0 over 0 is indeterminate form. This is indeterminate. So what is the meaning of indeterminate? This indeterminate means meaningless. So 0 over 0 does not have meaning. And because it is meaningless, it means it's not a solution. So we need to apply another method instead of direct substitution. And the method I would like to apply for this problem is what we call the L'Hopital's rule. What is L'Hopital's rule? L'Hopital's rule is a rule of differentiation. That literally means you should differentiate all of the parameters. But firstly, before you differentiate this expression, lim 1 over x minus 1 over x cos x as x tends to 0, the first thing I would love to do is to look for the LCM of the denominator. And of course, the LCM of x and x cos x, x can be found in, x can go into this without remainder. So the LCM of these two denominators is just x cos x. So the LCM of these two is x cos x. So here x goes into this, x will cancel out with x. All we left is cos x. Cos x times 1 is cos x minus the whole of this x cos x divided by x cos x, that is 1, and 1 times 1 is 1. So we are having the limit of the whole of this as x tends to 0. So at this point, what is the next thing we're going to do? Our v, we can make this our v and this is our u. Alright, so let's do that quickly. Let u be equal to cos x minus 1. And what is the next thing we should do? We have to differentiate this u with respect to x. So du over dx will be equal to, what is the differentiation of cos? This is a trig function. So the differentiation of cos x is minus sine x. So this is minus sine x minus differentiation of 1 is 0. Of course, 1 is a constant, so differentiation of any constant is 0. So we've gotten that. Again, v is equal to x cos x. This we can use through product rule because x multiplied by cos x. We can use product rule when we differentiate v with respect to x. By product rule, we keep x constant and differentiate cos x, which will give minus sine x. So we're having x multiplied by minus sine x. All right. And again, we need to keep this cos x constant and differentiate x. Division of x is just 1. So because it kept this constant, so we have plus cos x. This is normal product rule. All right, we've got in here. So we have that lim on the numerator. What we have is minus sine x minus 0 all over denominator. We have, maybe we can just bring it this cos x first. X times minus x minus sine x will give us x minus sine x. X minus sine x. All right, let's remove this so that we can be able to see it clearly. Let's remove these so it doesn't distract us. So this is what we're having. This is what we had from the numerator when we differentiated. This is what we have from the denominator. So of course, what is the next thing we should do at this point? We have differentiated both the numerator and the denominator. So what do we do at this point here? We substitute this value of x, which is 0, and if we do that, it means we have minus sine 0 all over. Here we have cos 0 minus 0 sine 0, right? So this will give us minus 0. Of course, 0 times this, the whole of them could be just pure 0, all of that, it's still the same. Here we have cos 0 is 1, and then we have here to be maybe you don't need this, minus 0 is just 0, and here 0 times sine 0 is 0, and we have 0 over 1. So what is 0 over 1? 0 over 1 is the same thing as 0. So 0 is the solution. I hope you enjoyed this video problem. I am Instructor Allison. Thank you for watching. I hope to see you in the next video.